Hello, on this video, we're going to see how to sketch the graph of a parabola. And perhaps it's going to be a bit different than what we're used to because right now we're going to be dealing with vertical and horizontal parabolas. And the first thing that you need to consider is that whenever you have a vertical parabola, the variable that will be squared is the x. When the y is the one that is squared on the equation, you will deal with a horizontal parabola. In this case, we have this equation, the y is squared. So we're going to be dealing with this information right here and a horizontal parabola. The first thing that you need to consider is that the vertex of the parabola is at h comma k. And you need to also consider that this equation can be written as y. And because we don't have an explicit value on k, we're going to assume that this is 0 squared is equal to 4 times p is going to be 1/2 times x minus 0. So right now, we're not going to be worrying too much about this value, but about the vertex. In this case, the vertex is going to be at 0, 0. That means that this parabola is at the origin. But this value right here is going to tell us the way this parabola is going to be opening. In this case, because we already know that it is horizontal, we have two options. It opens to the right or to the left. If this value right here, the 1/2 is positive, it will open to the right. If the value is negative, it'll open to the left. Because we have a positive value, or the p is greater than 0, it opens to the right. So without going into too much detail, we're going to expect the parabola to open this way. But we cannot just open it in any way that we want. We need to find a particular value for our parabola, at least one value. We usually go for the focus, but right now we're going to do it in the way that we previously knew. So because right now we have a horizontal parabola opening to the right, I can try to solve for x on this equation, and I'm going to have 2 times y squared is equal to x. Instead of having y squared equals 1/2 of x, I multiply everything by 2. So we usually try to see what happens when we have an x value and we try to go for the y value. Now we're going to do the opposite. Because I have solved for x, I'm going to be looking for an x value based on a y value. And let's say that I use 1 as my y value. So 1 is here. I want to see what happens to x when y is 1. So if I substitute y on this equation, it's going to be 2 times 1 squared is equal to x. So I'm going to get that x becomes a 2 whenever y is 1. So it's kind of like the opposite, because instead of having a vertical parabola, we have a horizontal parabola. And instead of substituting an x value, we're substituting a y value of 1 on my equation. And it's telling me that when y is 1, x is 2. So that means that my parabola is going to open something like this. And on the other side, I'm going to have a reflection of that value. So it's not a perfect sketch, but it will get me an idea of the way that this parabola will look. So as of now, just consider the vertex, then identify whether you're dealing with a vertical or horizontal parabola, and whether the parabola is going to open to the right or to the left in this case. Now, this is the first example, but we're going to do another one. We're going to see what happens when the x is the one that is squared. So right now we have x squared is equal to 3y. So let's identify the kind of parabola we have. Because the x is the one that is squared, we are dealing with a vertical parabola, and we can assume that this is x minus 0 squared is equal to 3 times y minus 0. It's just a way of dealing with the standard form of the equation of the parabola. And that way we can identify that the vertex is at 0, 0, right here. And because the 3 is positive, it means that it'll open upward in the positive direction. Now, we want to know, if we know the vertex, we want to know another point on the parabola to have an idea. Right now we're doing a very high level and general sketch. So if I have that x squared is equal to 3 times y, I'm gonna solve for y. So I'm gonna end up with x squared over 3 is equal to y, or y is equal to 1/3 times x squared. So right now, because y is the variable that I have isolated, I can pick a value on and substitute it here on x to find a y value. And in order to have a, let's say, a value that would produce more, or I would say a friendlier outcome, let's say I use 3. So I'm going to use 3. So I'm going to ask myself, what happens to y when x is 3? If I substitute that particular value on my equation, I'm going to have 3 squared. So that's 9. 9 over 3, that's 3. So whenever I use a 3, I end up with a 3. So the output is 3, 3. So that way I can sketch this graph. And on the other side, because parabolas are symmetrical, it's going to be minus 3, 3. So the parabola will go something like this.